Hello everybody, welcome to Red Education. We are starting with organic chemistry. I am a student who recently passed orgo chemistry with an A-. I attend the University of South Florida, and my goal is to help other students succeed in this class. So we're going to start with Chapter 1. Chapter 1 is extremely basic. It's pretty much a recovery of all the stuff you learned in Gen Chem. So let's get started. So organic chemistry is basically the study of carbon-containing molecules. Anything that contains carbon and the reactions that they're associated with is part of organic chemistry. So this could be bonds being broken, forming different products, one water going to another water, or it could be bonds breaking. What is this? The reverse reaction, etc. And throughout this videos, we'll figure out how each reaction goes, etc. The first thing we're going to learn is constitutional isomers. So constitutional isomers have the same formula. If you had C3H8O, you can draw it multiple ways. So we have C3H8O, we could possibly draw it like this. We could draw it like that, or we could even draw it like this. These two formulas are both C3H8O. And we could do it and look at it. Carbon 3, 1, 2, 3, hydrogen 8, 1, 2, 3, 4, 5, 6, 7, 8, oxygen. This side, carbon 3, hydrogen 8, 1, 2, 3, 4, 5, 6, 7, 8, and oxygen. So those are what constitutional isomers are. Extremely simple. The next topic we're going to talk about is called structural theory. So, if you would have noticed in the last example, my oxygen always had two bonds, and carbon always has 4. So this is what is a fundamental concept in organic chemistry. And basically what it is carbon will almost always be tetravalent. Tetravalent, meaning it has 4 valence, or in other words, 4 bonds. Then nitrogen will be trivalent. Oxygen will almost always be divalent. Then monovalent are your halogens and also your hydrogens. Halogens will almost be depicted as an X, but if we remember what our halogens are, They are fluorine, chlorine, bromine, and or iodine. These are your monovalent. So when it's very crucial when you're making Lewis structures, bond line, or any other thing, that carbon in its natural state has 4, nitrogen has 3, oxygen has 2, hydrogen and halogens have 1. You were given C2 and H7. Can you draw two constitutional isomers correctly and do it for the Lewis? Appeared, or these are the two answers you should have gotten. So remember, on a Lewis diagram, you need to show the lone pairs. So if you did not show the lone pairs above the nitrogen, you would be considered wrong in your answer. However, if we look again, carbon has 1, 2, 3, 4, being tetravalent. This carbon also has 4. 1, 2, 3, 4. The nitrogen, 1, 2, 3, and the lone pairs to make it have its octet rule. Then halogens and hydrogen, but in this case only hydrogen, 1, 1, 1, etc. And this is, if you can notice, C and C. This is C, C, and constitutional isomers. Both have C2 and H7, just in different orders. A quick reminder, back to oxygen names. A proton are +1. Electrons are -1. Now, we want to get more practice in making some Lewis structures with the valent or the structure theory. So, it's fundamental, and these will be a little bit difficult. If you were given O and H, would you know what to do? If you were given C, H4, O, would you know what to do? So remember, these valent rules, the structure theory rules, are extremely important. So what I'd always recommend doing is oxygen you draw it out, nitrogen you draw out, and hydrogen you draw out. So just from this alone, you know, oxygen needs 2, nitrogen needs 3, hydrogen needs 1. So you can kind of visualize if you combine the lines together, that if you drew it like this, if you drew it like this, you have no formal charges, and you follow all the octet rules and structure theory rules. Now let's look at it again. CH4O. Carbon has 4, hydrogen has 1, and there's 4 of them. And then oxygen has 2. So now, if we try to do like I said before, we do process of elimination. If we see, this one goes here. We see this one goes here. This one goes here. This one goes here. This one goes here. Oxygen is not even in the formula. So we know that can't be happening. Well, let's maybe say, well, oxygen and carbon have to be connected. So we go like that. Then we notice, oh, 4 hydrogens left. 1, 2, 3, 4. So we'd end up with carbon, oxygen, hydrogen, hydrogen, hydrogen. Now remember, valence electron, or the lone pairs. Do not show the lone pairs, you are wrong. Next topic we're going to talk about is formal charge. So I'm going to draw 3 different structures. Okay, so we know right off the bat that the first one is our neutral. We know it is because it's part of our structural theory rules and it has a full octet. I'll explain the math coming in a couple seconds. Now, the one next to it has an extra lone pairs, so this will have a formal charge of -1. In an organic chemistry, you mostly only have negative and +1. You don't go above that. And if you could assume, the last one have a +1, or what we know as just a plus. But if you were given a question where you weren't shown, you didn't know how to solve it. So formal charge will always equal valence electrons minus lines minus dots. Now, for valence electrons, you would need to look at a periodic table and what group they are, going up and down. So for example, hydrogen, lithium, sodium is group A, and if we look at our noble gases, helium, neon, etc. is group 8, fluorine, chlorine, bromine, iodine is group 7, oxygen is in group 6, nitrogen group 5, carbon group 4, etc. So, if you look at the group, it'll tell you how many valence electrons there are. So, if we were to do the math for this one, oxygen is in group 6, so it has 6 valence electrons. This one has 2 lines. So 2 lines, then dots, 1, 2, 3, 4. So as we know, 6 minus 2 is 4, 4 minus 4 is 0. As we said before, this does not have a negative or positive formal charge. Now looking at the next one, as discussed before, oxygen has 6. This one has 1 line. And then dots, 1, 2, 3, 4, 5, 6. So 6 minus 1 is 5. 5 minus 6 is -1. A formal charge of -1. The last one, self-explanatory, 6 minus 3 minus 2. 6 minus 3 is 3. 3 minus 2 is 1. So a formal charge of +1. And this can be done for any of them. So for example, I were to give you nitrogen, which what I'm showing you right now are going to be your major chemicals you see throughout all of organic chemistry. So if you can remember them, that would be easier over time. You will probably remember them. But if you just remember formal charges, formal charge equals valence electron minus lines minus dots. You will be successful. So again here, nitrogen is in group 5. So that's 5 minus lines, minus dots. 5 minus 5 is 0, etc. 5, 2, 4. Guess what? That's negative. Then 5 minus 4, no dots at all. Guess what? That's positive. And you can do this for even the halogens, etc. Very simple topic is formal charges. The next reminder, what we're going to go over back from Gen Chem. And like I said, all this should be recovery or barely relearning. You should have this already engraved. But the next topic is electronegativity. Electronegativity is how strongly an atom attracts shared electrons. So if we remember from our periodic table, electronegativity values increase as you go up and as you go right. So fluorine being most negative, Fr being your least negative, and electro. So why do you need to know electronegativity? Well, this is how we learn our non-polar, our polar, and ionic bonds. And in simplicity, non-polar is anything less than, so anything less than 0.5. Polar is anything that is greater than 0.5 and less than 1.7. Ionics, everything greater than 1.7. So what does that mean? For example, if we had a carbon, if we had a carbon bonded with carbon, 2.5 minus 2.5 is 0, non-polar. Or let's say if we had oxygen bonded with a carbon, well that's 3.5 minus 2.5, which is 1, and as we know, that would be a polar bond. So that's what electronegativity only shows you. It comes in later in the class, but if you understand that the fundamental concept is 0.5 is non-polar. It's less than 0.5 non-polar. Polar is between 0.5 and 1.7. Ionics greater than 1.7. This section should be extremely easy for you. So this will conclude Chapter 1, Part 1. Later on, we'll talk about reading bond line structures, etc. Any questions, put them in the comment. I hope you are successful. My future videos will probably be broken out throughout each chapter. However, this was just a lot of reminders, so I just wanted to put them all together. Well, thank you so much for your time, and I hope you enjoy my videos.